Understanding the physics of climate change and global warming involves grasping the fundamental physical processes that drive changes in Earth's climate system. Here's a step-by-step guide to help you comprehend the physics underlying climate change. Learn the basics of Earth's energy balance. Start by understanding Earth's energy balance, the equilibrium between incoming solar radiation, sunlight, and outgoing thermal radiation, heat. Learn how the Earth absorbs sunlight, reflects some of it back into space, and emits thermal radiation in the form of infrared (IR) radiation. Explore the greenhouse effect. Dive into the greenhouse effect, a natural process that regulates Earth's temperature. Learn how greenhouse gases, such as carbon dioxide, methane, water vapor, and nitrous oxide, trap heat in the atmosphere by absorbing and re-emitting IR radiation. Understand the role of greenhouse gases in maintaining Earth's habitable climate. Understand anthropogenic greenhouse gas emissions. Investigate the impact of human activities on greenhouse gas concentrations in the atmosphere. Learn about the burning of fossil fuels, coal, oil, and natural gas, deforestation, industrial processes, agriculture, and land use changes, which release additional greenhouse gases into the atmosphere, enhancing the greenhouse effect. Study climate feedback mechanisms. Explore climate feedback mechanisms, processes that amplify or dampen the effects of climate forcings. Learn about positive feedback loops, which amplify changes, and negative feedback loops, which stabilize the climate. Investigate feedback mechanisms such as ice albedo feedback, water vapor feedback, and cloud feedback. Learn about radiative forcing. Understand the concept of radiative forcing, the change in the energy balance of the Earth's climate system caused by external factors. Study different types of radiative forcings, including greenhouse gas forcing, aerosol forcing, solar forcing, and land use forcing. Learn how radiative forcing drives changes in global temperature and climate patterns. Explore climate models. Familiarize yourself with climate models, computer simulations that represent Earth's climate system and predict future climate scenarios. Learn about the components of climate models, including atmospheric, oceanic, land surface, and cryospheric components. Understand how climate models are used to simulate past, present, and future climate conditions. Study climate observations and data analysis. Investigate climate observations and data analysis techniques used to monitor changes in Earth's climate system. Learn about instrumental records of temperature, precipitation, sea level, ice extent, and greenhouse gas concentrations. Explore satellite observations, paleoclimate data, and proxy records used to reconstruct past climate variability. Understand climate variability and change. Explore natural climate variability and long-term climate change trends. Learn about phenomena such as El Niño Southern Oscillation, ENSO, the Pacific Decadal Oscillation, PDO, the Atlantic Multidecadal Oscillation, AMO, and solar cycles. Understand how human-induced climate change is superimposed on natural variability. Study climate impacts and risks. Investigate the impacts of climate change on Earth's systems, ecosystems, and human societies. Learn about the consequences of global warming, including rising temperatures, changing precipitation patterns, sea level rise, extreme weather events, biodiversity loss, food and water insecurity, and public health risks. Explore regional climate impacts and vulnerabilities. Explore climate mitigation and adaptation strategies. Learn about climate mitigation and adaptation strategies aimed at reducing greenhouse gas emissions and minimizing the impacts of climate change. Study measures such as renewable energy deployment, energy efficiency improvements, afforestation, carbon capture and storage, CCS, climate resilient infrastructure, and community adaptation initiatives. By following these steps and deepening your understanding of the physics of climate change and global warming, you can gain insights into the mechanisms driving climate variability and change, as well as the implications for Earth's ecosystems and societies. Empowered with this knowledge, you can contribute to efforts to mitigate climate change, adapt to its impacts, and build a more sustainable future.